Welcome, everyone. Kevin Carpenter, and I'm with Patrice Roy, and we're with GOTO Book Club, and we're here to talk about Patrice's new book, Memory Management in C++, which I have to say, Patrice, I love chatting with you, but I always love picking on your experience, and I'm not great with memory management, which is why I'm here with you.
Well, I don't believe you, but you're very sweet.
Let's just say, okay, so in a little bit of a cheat note, I did get to edit your book, right? And that was one of the reasons why I'm so happy to get to talk to you about it, because when I got offered the opportunity, I'd already done one book with PAC, and they're like, well, we have this other project. I'm like, I don't want to do another project. And they're like, but it's Patrice Roy, and he's got, it's Patrice. Okay.
You're very nice. You're very nice. It was an honor. I was granted very good technical reviewers. I was lucky.
So, okay, I can tell everybody a lot about you, but introduce yourself, because then you can give your credentials, which I definitely won't. All my experience is personal.
My credentials. I've been programming since the 1990s, early so. So I've been doing C++ for way over 30 years now. I used to do military flight simulators. I've been teaching since 1998 to both undergrads and grads. I work a lot with video game programmers, and I've been a member of the C++ Standards Committee since late 2014. My first meeting was the May 2015 meeting in Linux in the US.
Nice. So, of course, I was going to say, I know you from all the CPPCon conferences, all of your classes, because, I think we've talked before when you're doing your classes and the conference classes. But when I think of things that I've seen you do before, like this to me was new, memory management. I mean, I know obviously with all your experience, you've got a deep knowledge on it, but am I right? This is like your first book or your first, because I don't remember you doing any classes on memory management.
Well, in fact, I have.
Okay.
At CPPCon, I've done a few. That book was interesting in the sense that after doing the memory management class at CPPCon 2 or 3 times, I think, I was giving that and thinking small, something to write small programs. And that's where PAC approached me and said, well, would you like to turn that class into a book, maybe? Which, okay, it's an interesting challenge, and it's a very different experience. I like doing it, but it's not the same thing.
No, it is not. And I mean, writing a book, I mean, that is definitely, I've been there. I tried that, and I'm glad you succeeded, and I got to read it because it's a great book. So I have to say, so in your mind, what is one of the hardest concepts for memory, for someone who's new to C++, memory management? In your perspective, what's one of the harder concepts for new C++ developers to pick up?
The people do too much of it.
Yeah.
So we get people who come from an earlier C++ background from way back, or from other languages where they have garbage collectors, say, and they tend to try to allocate memory dynamically themselves all the time. But C++ works best with value semantics. It works best with objects. So we do too much of it. The book is not to tell you, never do it. But if you need to do it, now here are some ways to not get yourself into trouble and to get success out of it and everything. But most of the time, you shouldn't use it. The point of C++, the best angle for C++ is to kind of avoid this thing unless there's a need. But there are needs, and I think there was a need for the book.
Do you think a lot of that need, and I'll ask this more specifically later, because it's like I definitely have code bases that I've worked on that are Microsoft Foundation classes, and that I think ages itself right there. Yeah. But with all the talk that we went through in the past couple of years about security and everything else, knowing how to manage C++ memory right keeps security solid. Would that be a fair statement?
Yeah.
Or it assists in it?
Well, we have all the tools to do things right these days. So the metaphors that we're using with iterators and algorithms, they reduce the number of bugs tremendously. We have good containers that handle memory for us, vectors, strings, and such lists. They're good at what they do. So when we do need to write them ourselves and get our hands dirty, we have to know what we're doing. But all the tools are there to do something safe and clean. There's still some subtle things with lifetime in C++ that are hard to solve, like binding to a reference to something that's not there anymore. We can get in trouble with that still today, but we are getting better. The book is not about safety, but it does emphasize proper ways of doing these things without getting too much in trouble. Yeah.
No, and that's where I agree. It is definitely not about safety, but I think of the way that you've written things, the way that you pull a lot of comments where it's like, okay, you can do this, but if you're doing it, you're probably doing it wrong. Or if you're doing this, remember, it's your own foot you're shooting off, and you really shouldn't do it this way, kind of thing.
I did take a risk. You remember, you read the book, so remember one of the early chapters is things you shouldn't do, really.
Yes.
but when we go low level, we have to do them sometimes. But
yes.
If you have to do them, please do them right. Please understand that some things, they might work on your compiler, but they're not really working. It's just an accident, really. or it's just something non-portable, and you're gonna get into trouble. But there are tools. They exist.
Yes.
This is C++. You can do what you need to do. Do it right. So yeah, I thought it risky to put a chapter early on things you shouldn't do. It felt weird, but it seems to have worked. So I'm kind of happy about that.
But I will say, like, in all of the chapters, the thing that I really liked is your code examples and the way you wrote the code examples. Like, some of them are really concise. And what I mean by that, it's not like I'm going to necessarily copy out the particular piece of code, drop it in the compiler, and make it run. Now, that doesn't mean you can't, because I tested every piece of code. But the way that you wrote the comments in a particular piece of code, like you're showing how if I assert this value, it should be this. If I assert this, it should be that. But then right there clearly in the code, you're like, this assert's going to fail because we shouldn't have done it this way.
Maybe it's a tick or something like that. I've been teaching for a long while.
Yeah.
So I like examples that convey information in few words without being too obscure. I'm trying to do that. It's not always possible. You might remember the later chapters where I deal with containers. When you do get your hands dirty and do the very efficient level memory management stuff, it's hard to understand. It's something you need to test. But I try to keep most of them small and understandable. I'm glad if you're telling me it shines through. I'm very happy about that.
Yeah, no, and you're absolutely right. As you get into those later chapters when you're building your own container and such, I was definitely putting that code in the compiler, stepping through it. But still, the way that you would document the code, it's like, we talk about writing self-documenting code, and that's one thing. But when you're writing it as an explanation, the way you would do the asserts and the comments just made it flow like reading. You'd read the concept in the paragraph, and then it was very clear in the code example exactly what you meant. And I have to say to everybody listening, like, when I came into reading your book, yes, I know pointers. I made the point about an old MFC app, which I do want to hit on, because in that app, we actually do pointer arithmetic over a array of doubles that's probably 400 or 500 megabytes in memory, right?
Beautiful.
and it's incredibly fast. So it's like, and to that part of me was going, I got to ask you, when you consider like std array, which of course would give you your finite size and make it so you can't run off the end and give you all those kind of safety items, do we give up a lot in speed if you go from an old C-style array of doubles, I'd say, to using std array?
It's not the same use case. So in your class, you probably, if you don't know the size in advance, you're going to need to allocate something. And if you want to pointer to an array, SD array, you will have to specify the size there. So it's not going to match what you want to do. You could use a vector and you'll be very fast though. And as long as you reserve once and then allocate the thing, it's going to be blazingly fast too. And if you look at what pointer arithmetic does, I mean, it's the same thing as the array operations with the square brackets. One translates directly into another. You won't be losing speed with this. But I don't think SD array would be your use case if you're using dynamically allocated stuff, unless it's always the same size. But that doesn't sound like that to me.
Yeah, I was going to laugh and say, well, of course we know the size. It's a macro because it's MFC. And it's like, we have this many lengths and this many widths across this many accounts. And there's probably 4 or 5 other macros that are just, I've been trying desperately to move to const expert, but the code is old and brittle. So, there's that.
Mind you, if MFC still compiles, given the idioms of way back then with today's compilers, which is something I would have to check. I haven't used that library in about 20 years now. but I'm sorry. But I did use a pre-98 compiler 10 years back for real-time systems. It was an experience to get my old backup tricks out and just rewrite everything. But what you're referring to, you might be tempted to use MD-SPAN maybe. The new span stuff from C++23 will let you do proper indexing very efficiently without having to go too level and dirty yourself.
Interesting. I will have to take a look at that. I mean, because we are building with C++17. And to that point of other chapters you have in your book about, because I was just re-reviewing it last night, shared pointer versus unique pointer and weak pointer. And even there, your examples that you give, we probably use shared pointer more than we should, because in some cases, as they adapted the app, too many things are being accessed everywhere. But at least you're getting the extra protection of having that reference count versus a raw pointer.
Yeah, but the idea of shared pointer is not having many users. Raw pointers do that. It's having many responsible bits of code over the lifetime of your object. So if you have a single last user of your code, you don't need a shared pointer. Well, in most cases, unique pointer does the job. It's a matter of responsibility. Sharing data, raw pointers work fine.
They do. And that's the part where I've been kind of torn. It is a Windows app that is double the complexity of an Excel, because it manages it manages some of the largest financial institutions' balance sheets that in the United States here. And so the interesting part about it is that with that code's age, as you try to bring it in and you bring in more modern parts, then it's that little bit of a double-edged sword. There's parts that when you write something new, you're starting to write things more modern, but then you still have that raw pointer access that's going on, as I was talking about, which is very efficient. But when I think of the chapter in your book in the early on where it's like, you really don't want to use raw pointers unless you have to, as you point out. And that's the part where I'm like, I do like how in the book throughout it, you point out the things to be, it's not don't use it. It's, are you considering these 3, 4, 5 or whatever items if you are using it, right?
The kind of message we're trying, the committee members, I think these days, what we're trying to convey to our users is that if you get a raw pointer as an argument to a function, it's telling you you're not responsible for it. Use this thing, be an observer of it, consume stuff, but don't take it as your own. Don't try to delete it or reallocate it, unless that's the mission of your function, of course. If you're writing reallocate something else. So yes, raw pointers are fine for that. So what you often see, especially with legacy apps like yours, is the owner is a unique pointer, say, unless there's co-ownership. And then you use the get number function, you get a raw pointer, and you provide this to non-responsible for the pointee functions, and it all works like fine. There's no overhead at all.
Yeah. So let me back up again a little bit to the point of, someone new coming into your book. I've got 15 years writing C++ straight, not counting the years of off and on before that. So, but I was always more of an application writer versus library, and I consider that code a little different. But my point I want to get to is, so someone new to C++ coming into this book, can you think of like 3 things out of your book that you would really want someone new to C++ to take away from it?
Yeah. I did make an effort, I think, to promote best practices for writing new code. So try to wrap your memory management into objects that you can test and that do the job right, or use the standard library provided ones. They're very good, vector and stuff. They're awesome. So if you do that, that's cool. C++ there are easier to use tools. I'm sure there are, but it's that tool that will get you where you need to go, no matter what you have to do. It's very good for that. So I'm hoping that someone will understand, reading through that book, that yes, there's tricky stuff you can do with it, but there are reasons. And you there if you can measure a need, and that's fine. Now you know how to do it if you're stuck. I'm hoping that newcomers won't try to write allocators for every container that they use. The standard ones are very good. But if you have a specific need, here's how to think about it. Here's a way at least to approach this. I tried to offer alternatives too. We have new kinds of containers and allocators these days, the PMR stuff. There are upsides to these, downsides to these. I'm hoping that people will be able to weigh on these things and make informed decisions. So if someone newer, but maybe this is not a beginner's book, but someone who's a junior in C++, say, or
Right.
C++ from another language, gets from this book, I'm hoping it's like sound practices and the reflex that they will sit down and think before they act. And when they need to act and use the tricky stuff, well, they'll do that in an informed way. I hope to have responsible programmers with me.
I can agree and see all of that, especially as I'm thinking through the chapters of the book. You did say something there where it's like, you hope somebody who's new to C++ after reading the book doesn't come in and write their own custom allocators because,
Unless there's a real need, but when you're beginners, normally that's not the first thing you do.
Right. And so, but that's that part where I'm like, if there's a real need. It makes me think of a talk. So a talk I gave last year was called Almost Always Vector.
Yeah, I was in the room.
Yes, you were. Okay. So, but I think you get my point then, right? Because that's kind of that part where similarly, you don't need to write a custom allocator, but if you did, here are the reasons why. And so I think of some of the memory patterns, like, and this might not necessarily apply to a custom allocator, but when you're talking about like the arena pattern and the ways that you would allocate memory, because depending upon the particular type of object that you're creating, if you're creating multiples of them, then you can gain that kind of efficiency. And so that might be the way or the reason you would write a custom allocator, right?
Yeah, maybe you can measure an actual gain. The point normally with these things is that your standard tools are very good on average. They're very good. But when you know the context and you know things about the data and the way it's going to be used, consumed, and handled, you can always do better because this is not the average case. It's something you know stuff about. But
right.
You have to measure a need, of course, because you're going to spend time on this thing. You're going to have to debug it and test it. So there has to be a need, a reward tied to this. But if it does bring rewards, I mean, the things I do in the book, they're funny a bit. I kill orcs, but it's blazingly fast. It's very, very fast, but the conditions make it possible. Another thing that I don't touch as much in the book, I could have, it's a matter of size and number of pages at some point, it's instrumentation. You want to know where the data is. I work with against people a lot. You want to know if there's cold regions in your game, hot regions where lots of people are coming in. Well, if you write an allocator, you can track these things and you can know where the blocks are allocated here and there. So there's ways there to optimize your code a posteriori, afterwards, just because now you know how the thing is being used because you instrumented the thing. Maybe not as people are, well, maybe if it's fast enough, maybe as the game is going on, maybe in your laboratory when you're testing stuff, but you can write allocators because you want to know where stuff is. Mm-hmm. This is, in both cases, arena style stuff and instrumentation stuff, PMR makes it easier than the old style allocators. But there's costs. PMR, you're incurring a virtual function call every time. So it's a matter of simplicity with respect to efficiency. You have to know where your needs are. But this is C++, so we give you tools. You build with them,
But to your point, the measuring and knowing where and why, because how does that saying go? Like, pre-optimization is the root of all evil or something?
Be careful. That quote is always incomplete. So they're saying 97% you don't really need it, but on the 3% where you need it, you better be able to do it.
No, and that was where I was going to say, like, to a point, your book to me really addressed when I need that 3%, like the examples and the knowledge that you detail in there. When I find the spot that is definitely eating resources, whether it be from allocations, being inefficient or such, then what I got from the book was exactly how to fix that.
Yeah. Well, there's other things that we ignore when we do day-to-day C++ programming. When you need to access exotic memory, something that is different from your normal RAM. So you want non-volatile stuff. You want shared memory. C++ doesn't delve into that as a language. We don't talk about processes in C++. We talk about threads. We don't talk about the operating system all that much because it's outside of our purview, let's say. But we do have tools in C++ to let you interface with those other things efficiently. And this is another reason why the book might be interesting to some people. Sometimes you are using something operating system specific and you want to map it to your C++ code in a nicer way, in a more agreeable way maybe than doing it the C style, I'd say. So there's a whole chapter on that. I hope that these exotic cases, well, when you face them, sometimes you're kind of stuck. How do I do this properly? And the book helps you.
As you were talking about the way that you map data structures and stuff, it's something small but it kind of made me laugh at myself because it made me think of the part where inside the book you're talking about padding. And it was interesting because I never really thought about it too much beforehand. But then when I would go back and look at some of the data structures and simply changing the order suddenly saved 16 bytes of memory on an object that we were creating 100,000 of because it was, a particular type of credit card transaction or something and just over and over. And it's like, some things that I would call little gems. It's like once I got it, it was hard to unsee, and so.
That's insane. Alignment. People coming from other languages, they don't know about this. But since this is one of the peculiarities of C++, we let user code see the actual addresses of things. So because of that, we cannot tell the compiler change the order in which the objects are, because the order in which we put them has meaning and is observable elsewhere in the code. That's something that's different in other languages, but we see these things. So if we put things without taking care of alignment, or without considering it, yes, we can make the objects significantly bigger than they should be, maybe. But you have to be careful. There's other considerations. When you have multi-threading, sometimes you want to keep things apart. Sometimes you want to keep them close by. It depends on the kind of code you're writing. But you have to be aware of that to be efficient. And yes, indeed, if you want to use your cache efficiently, well, alignment has a big effect on your size and thus on your speed today. It's crazy.
So that makes me think with the cache alignment and such. So that takes me back to the part that you have in there about shared pointer when we're looking at that and about, whether you use shared pointer or make shared. And so I'm curious, in your experience, what is that difference like of having the counter ending up being on a separate cache line from the rest of the allocation? Is that does that end up becoming a big performance hit depending upon the type of objects that you're creating and the speed of them?
Well, the short answer is yes. The longer answer is it's kind of fun. When I teach that thing in a classroom, I mind it. I take students on different tables, and one of them is the counter, the other one is the pointer to the object. But the thing is, you have to, with each access of your shared pointer, let's say you pass it to a function or return it from a function or something like that, well, you hit 2 cache lines at once. So there's a limit to the number of cache lines that you can access efficiently in a machine. So you're taking them away for no reason. So there's less left to do other interesting stuff. So yes, it will do measurable. It will mostly measurable impacts on your program and on the quality of your life.
So it's fair to say, well, I think it's fair to say in the C++ community, we definitely have the high frequency trading, which I think of where these things are a big performance type item. Then we have games, of course, embedded where you're really constrained on your resources. What I kind of laugh at myself about, so the day job, I work credit card transactions. We're processing billions of dollars a day. And generally speaking, I am not worried about cache line hits.
It's probably because of the size. It's a matter of size. Your problem space is so big.
Exactly.
Do they come in as arrays of transactions?
So in a way, yes. I mean, a lot of our transactions, we do a bunch of JSON, which ends up, of course, representing as a map, as a stood map. And then actually, as they are passed down through the system, they finally end up becoming raw, pretty much arrays of data, whether it's arrays of unions or what's the word I'm trying to say? Once you break down, it's like the actual credit card transaction itself comes down to an integer, another integer, and another integer.
Yeah.
You know, because the card number represents as an integer, the date represents as an integer, and what people don't realize is actually the dollar amount represents as an integer.
Yeah.
In the specifications. And so, yeah, that part ends up getting passed around really quick. And so it's interesting because as the data comes in and we're actually working with it, it trims down before it actually gets processed, because you actually, you know, it's like you go to charge your hotel and they're actually sending, you had a queen bed in your hotel room and everything else in the transaction because of fraud controls. But then, of course, it does break down the data. But to your point, the problem space is it's just huge, right? And so but that's the part where it's like, there's a lot of tips that I got going through the book that makes me look at the code that I write now differently and with more care.
I'm touched. Can I ask you a question, though? When you're processing your credit cards like this, do you do mostly reads, or do you also do some writes to the array? Because that will make a big difference in your code. If you have two cache lines accessed concurrently by two different threads in your code, one of them does a write, it's going to wreak havoc in your performance. But if you're doing reads concurrently, nobody cares. It's going to be very fast.
So there's two sides of credit card transactions. One is the authorization, and that's a pretty not parallel, but concurrent situation, because they're all coming in at different times. And so you're handling one at a time. But that part happens. That's when you swipe your card at the restaurant. But at the end of the night, when they go to process, that's when we're turning around and reading 20,000 transactions in one line, processing them through and then writing them out somewhere else. The typical programmer, we read from databases to process to write back to databases.
Awesome. So this is very linear stuff that you can do without concurrency at all if you don't need to. The cache will be efficiently handled in this case. It's probably different from the shared pointer case you were referring to, where you're allocating dynamically the counter on one side, the point T on the other side. So you got two pointers, one besides the other. And if you keep them close, since you're using them together most of the time, it's going to be more efficient.
Gotcha. So, real quick, one last, because I know we got to wrap up here at some point. So I have a little bit of a leading question, but I have to say, so your book, the little bit of template stuff that is in there was, because I am not a template programmer by nature either, just as like I learned memory management from you. But when it came to template programming, it's the kind of stuff that I think we all expect just using C++ in a way. It's like, you know, you're using std vector. We know it's a template. We don't really think of it because we're not writing it as a template. Same with std pointer. Now, in some of your examples, when we start writing our own container, even that little bit of template stuff was, I'm going to say template easy, kind of like I didn't need to know a lot of template foo, as we would say, in order to go through your memory management book.
You're very sweet.
But is that generally the case with the memory management, that, you know, it's template stuff, but it's not like getting big into generic programming, right?
No, I'm sure you can find use cases for complicated stuff if you look for it. What I tend to find useful, do you remember there's a chapter on deferred reclamation, kind of garbage collector-ish? So if you want to finalize the objects you're pointing to, it's kind of nice to remember somehow what you were pointing to. So being able to wrap this in a function that itself remembers the type of the thing you have to destroy, it's kind of a neat trick that I stole from Kazuniri. I love it. So there's these tricks there that are template-ish, not necessarily too hard, but mixed with function pointers, you can go a long way with that.
Yes, I do remember that. That's very cool. And I have to say, some of the other parts that I really liked when you broke into new and delete and the details of how new is actually a two-step operation, and then you're customizing new so that you can turn it into a tool to watch your allocations and deallocations. And so, but back to my generic part. So next we're going to work on a generic book, right?
Yeah, we started working on that. My next book, the first chapter is written now. It's done. I think it's going to be nice. I'm trying to, the way I'm approaching this is, again, turning one of my classes into a book. But of course, it's never the same thing, as you can know. So I gave a class a few years back called Generic Programming from Strange to Normal. So it starts looking weird and wondering why you would use that thing and what are the benefits. And then you're progressing and learning stuff, gradually speaking. You're having fun, and at some point it just becomes normal programming, and that's the beauty of it. And I can get you there with C++ because it's such a cool language. So first chapter right now, I'm working on developing an intuition of what's the point with this thing. And if you have questions about deeper template programming, I'm going to get there. But I'm planning this not as an expert book, as a book for someone who wants to understand what he or she is doing going through this. So there will be explainable stuff, but I'll build all the way to make it understandable for people. So I'm hoping that they will be as happy with this book as you were with the memory management book, and that they will think that they learned something and understood something from it.
Well, I do look forward to that. I really do, because generic programming is also not something that's my forte. I do want to end with, I think Patrice has made clear, like, this is not, if you're first and new to C++, even, this is not the first book you want to pick up. But I want to say from my experience going into this, even with 10 years of programming or less, I never really, outside of some raw pointers and such, I didn't do a lot of memory management. I certainly didn't do things to the level that Patrice has in his book. And so, whereas there were chapters that I definitely pored over more than once, the book was really accessible. Like the examples, as we kind of talked about, really were easy to follow, even if it took me once or twice reading through it, and I think there's a benefit to that, right? You're doing the mental CPU work, which is where I think we really learn. At least for me, it's like that trying to lift a weight up the first time. It's a bit of a struggle, but then once you get it, you're like, oh yeah, that. And so, yeah, if you haven't read the book yet, you want to pick up a copy, and your memory management foo will definitely improve. That is for sure.
You're very kind. And if you find bugs or things that you want to talk about, write to me. I'm going to be happy to speak with you.
That's excellent. So Patrice, I really appreciate your time today and talking about your book, and I look forward to when we can do this again about a generics book.
It's always a pleasure, my friend. Thank you so much.
Thank you, Patrice.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.